Today on Radio Boat Anchor, I'm going to repair this vintage 1987 Radio Shack Micronta 4003 VLF metal detector. The Micronta 4003 VLF metal detector was first introduced to the public on page 59 of the 1987 Radio Shack catalog. This metal detector, catalog number 63-3003, was advertised as having the following attributes: very low frequency circuitry that identifies buried valuables even in highly mineralized ground, waterproof 8-inch search coil that can detect objects even in shallow water, auto-tune for optimal sensitivity, built-in meter and speaker for visual and audible indication. Testing. Batteries must be installed in the Micronta 4003 VLF metal detector in order to test. Notice the handle has made its way free of the control box and will need to be repaired. The battery compartment cover is located on the bottom of the control box. It must be removed in order to install the 3 required 9-volt batteries. One of the 9-volt battery clip terminals was broken on this metal detector. This 9-volt battery clip will need to be replaced. I used an alligator clip test lead to connect the 9-volt battery to the broken battery clip for testing. I then set this metal detector's controls to the following settings: the ground control to mid position, tune to mid position, and sensitivity to maximum. In addition, I set the discriminator to minimum, mode to VLF, volume to 75%, and test to normal. You must perform an auto-tune before any metal detecting. Auto-tune is accomplished by holding down the red auto-tune button and rotating the tune control while watching the meter until it is centered at 0. Time to perform the quarter test. As you would see, there's no change in audio tone when the quarter is moved under the search coil. There is definitely an issue with this Micronta 4003 VLF metal detector that needs to be addressed. Repair. Some disassembly is required before repair. Step 1 was to remove the batteries, which are located under the battery compartment cover on the underside of the control box. 3 9-volt batteries must be removed from their battery clips. The search coil connector must be disconnected from the control box and the wiring unwound from the adjustable stem. 2 thumb screws must be removed in order to remove the search coil from the adjustable stem. This lock nut on the adjustable stem must be removed in order to separate the top from the bottom adjustable stem. The top of the adjustable stem is built into the control box. There are 2 isolated coil windings in the search coil. A coil winding resistance of approximately 20 ohms should be between these 2 pins on the search coil connector, while coil winding resistance of approximately 60 ohms between these 2 pins on the very same search coil connector. The ground, tune, and sensitivity knobs must be removed from the control box top, and the phone jack must be unscrewed from the control box top as well. In addition, the discriminator, mode, and volume knobs must be removed as well. 3 screws must be removed in order to separate the bottom of the control box from the top. The 3 9-volt battery clips must be pushed through the small openings in the battery compartment. 2 screws must be removed to free the speaker, and the search coil connector removed from its mount in order to completely liberate the control box bottom. 3 screws must be removed in order to liberate the adjustable stem from the control box top. 4 screws must be removed to free the printed circuit board. I desoldered the 2 blue wires from the auto-tune button on the handle, and the black and red wires that connect to the meter. It is much easier to work on this metal detector's printed circuit board once it has been freed from the control box top. I have determined that there are 2 electrical issues with this metal detector. First, there is a broken terminal on one of the 9-volt battery clips. I used an alligator clip to jumper during testing. Second, the auto-tune button was broken. I temporarily soldered a momentary normally open switch in place. Initial testing was successful after I calibrated the metal detector by holding down the auto-tune button, then turning the tune knob until the meter was zeroed. I decided to replace all the 9-volt battery clips, even though only one was broken. After I soldered the wires in place, I used a little E6000 adhesive to provide strain relief to the wires entering the 9-volt battery clip. Here is a picture of the replaced 9-volt battery clips. There are 3 electrolytic capacitors on the printed circuit board. It is a good idea to replace the electrolytic capacitors while you have the control box apart. After 38 years, electrolytic capacitors lose their capacity as their electrolyte dries up. It is important to replace the electrolytic capacitors with the same capacity and the same or higher working voltage. It is also important to observe their polarity when installing. Here are the new electrolytic capacitors soldered in place on the printed circuit board. I used the Oxid D5 contact cleaner to remove oxidation from the potentiometer's resistive traces. The Oxid D5 was sprayed into the opening on the bottom of each potentiometer. I then worked the contact cleaner in by moving each potentiometer through its full motion. The Oxid D5 was also sprayed on the contacts of the mode selector switch, through the small opening in the volume control power switch, and into the openings on the test selector switch. Labelle 107 model train oil was applied to the shafts of all potentiometers, the shaft of the mode selector switch, and through the openings in the test selector switch. Time to retest the printed circuit board. There is an issue with the auto-tune momentary switch in the handle. 2 screws hold the 2 halves of the handle together. Looks like parts are missing from the original auto-tune switch. I drilled a hole through the center of the auto-tune switch printed circuit board. Then soldered a micro switch in place upside down, so that the micro switch plunger went through the auto-tune switch printed circuit board. The micro switch assembly was then reinstalled in the handle, with the original auto-tune red button on top. The handle's 2 halves were then secured together with 2 screws. This metal detector's handle is broken. The shafts that secure it to the control box top have sheared off. I secured the handle back to the top of the control box using 6 self-tapping screws. 3 screws to hold the front of the handle, and another 3 smaller screws to secure the back of the handle in place. Unfortunately, 2 screws that hold the back of the handle in place to the control box top are visible. There is not a lot of plastic on the back of the handle to secure it in place. Reassembly. The control box bottom was thoroughly cleaned with my go-to cleaner, Windex, then treated to a coat of Armorall to bring back the luster of the plastic. The same Windex cleaning and Armorall treatment was applied to the control box top. In addition, the battery cover and knobs were cleaned with Windex, then given a sheen with Armorall. Mr. Clean Magic Eraser did a great job of cleaning the search coil housing and cable. The search coil housing and cable were also treated to a coat of Armorall. Finally, the adjustable stem was cleaned with Windex. I used 2x4 wood blocks to help support the control box top and printed circuit board during reassembly. The auto-tune momentary switch wires were soldered back to the printed circuit board. Then the meter wires were then also soldered back to the printed circuit board as well. Time to flip the printed circuit board over to the component side and reinstall it into the control box top. At this time, the search coil connector was reinstalled into the control box top as well. 4 screws hold the printed circuit board in place. The phone jack was then reinstalled into the control box top and held in place with a chrome flat washer and a nut. The adjustable stem was then mounted into the control box top. I had to replace the long threaded screw that held the adjustable stem in place with a short self-tapping screw and washer. The long threaded screw originally connected to the broken handle shaft. The self-tapping screw with washer was used to fasten the end of the adjustable stem. A plastic clamp with 2 screws provide additional support to the adjustable stem. The speaker is mounted to the control box bottom with 2 screws. The 3 9-volt battery clips need to be routed into the battery compartment openings. I had to replace another long threaded screw with a short self-tapping screw. The long threaded screw originally held the control box bottom to the top and connected to the broken handle shaft. The control box bottom was then mated to the control box top. 3 screws hold the control box bottom in place, with the new short self-tapping screw going in the center hole by the speaker grill. This is the perfect time to install the 3 required 9-volt batteries. The battery cover was then installed. A nameplate is located just above the battery compartment. Time to install the knobs. It took some time to get the indicators on the knobs properly aligned. I then installed the rubberized cover on the phone jack. The top and bottom of the adjustable stem is then joined together. Once connected, I turned the lock nut clockwise to secure the top and bottom of the adjustable stem in place. The search coil was then installed on the end of the adjustable stem. It is held in place with 2 thumb screws. The search coil wiring is then wound around the adjustable stem, and the search coil connector is then connected to the control box. At this point, my Radio Shack Micronta 4003 VLF metal detector was ready for action. Conclusion. The Northeast Ohio winter weather prevents me from testing outside, so I decided to test this metal detector in my basement using the quarter test. As you can see, my Radio Shack Micronta 4003 VLF metal detector has been repaired and is ready for action when the weather turns warm. Please like this post and subscribe to Radio Boat Anchor so that you're alerted to my future posts. Thank you.